So let's talk about custom packages. And it's not enough to just use all the stuff that's available on NuGet, on NPM or Bower, etc. It might be useful for you to develop your own packages. And let's go back to my kitchen sink example. I have a DLL that needs to be used by the entire development team or multiple development teams. And we need an efficient way to distribute that to everyone on all the different development teams. So how do we do that? Before I show you the how, let's talk about the what. What should you package or what could you package? And we're specifically talking about NuGet packages in this case, but the same lines follow with NPM or all the other package managers. With NuGet packages, we can package .NET assemblies, and not just .NET assemblies for one version of .NET. I can deploy .NET assemblies for multiple versions of .NET, or for .NET Core, or for Portable. We can push out PowerShell scripts. So maybe I want to not just install a package, but then I want to run a script that sets up the environment. NuGet will do that for you. Content. If you've ever installed something like a jQuery or a modernizer installs JavaScript, it might install CSS or images. It dumps all this stuff into your solution because it's required for the greater package to exist. And there's really 3 steps to packaging. You'll have to get the NuGet command line tools. This is why I said if you want to follow along, have your command prompt or your PowerShell already up and running. We'll teach you how to build first a basic project or a basic package, and then we'll go a little bit more advanced. And then, I'm feeling like having some fun, so maybe I'll push that package up into NuGet, and you all can go download it, do whatever you wanted to. So step 1 is you have to get the NuGet command line interface. You get this by going to nuget.org/downloads. It's just an exe all by itself. This might exist on your system in some way, shape, or form with different versions of Visual Studio. You might not want to trust those versions. It might be outdated. But if you go to nuget.org and get the latest, that way you always have it. The most important thing is that you put this in a location on your machine that's accessible via your path. And the reason we want accessible via path is I want to be able to say NuGet anywhere I am at the command line. And we'll talk about here in a moment why that might be important. So let me go to nuget.org/download. All right, so we have different versions of the NuGet executable. I have the latest 4.4.1, but you could get older versions if you need it. Visual Studio, it's built in. You already know that. Or if you have different versions of Visual Studio, we can get older versions of NuGet that are all available. Now, I already have it installed, and so I created a special folder. So if I go to environment variables, let's see, which path did I put it in? I put it in one of these paths. Yep. So I have a folder called tools. I have NuGet in there. So because it's a part of my path, anywhere I am on my computer, I can get to NuGet. It's all available to me. Now, if you run NuGet, you'll notice there's a lot of subcommands that can get run. And this is the similar NuGet that gets run by Visual Studio when you go to the NuGet manager. So you could add packages from the command line. You can initialize a new project altogether. We'll do a lot of stuff with the command line. You don't need to know all these different commands. In fact, the only ones we're really going to look at are pack and probably push and then set API key. The rest of these we're probably not going to do too much with. And spec a little bit later. Yeah, so the 3 commands I think you really should know something about is the pack command. The pack command is what builds the NuGet package or the new package. And there's a couple different ways to do this. We can point it at a simple CS proj file, and the CS proj file will go look at the dependencies for the application. It will also look to see where the build targets are. So if it gets built and then deployed to your bin/release folder, it knows to go grab those items and then build a NuGet package. If we want a little bit more flexibility in how the NuGet package gets built, we can then create a new spec file, which is, it's a definition, it's a manifest of how a NuGet package should be built. I'll show you how to use that as well. We'll do it the basic way first, then we'll do it the slightly more advanced way. If you're ready to take your NuGet package and you want to push it up to NuGet, we can use NuGet's set API key to tell NuGet who we are. You have to make sure you have an account on NuGet before you push anything up to the public repository. And you do all that connection with API keys. And then finally, NuGet publish takes our new pack file, which is the NuGet package, and sends it up to NuGet.org. We're going to walk through that entire process right now. All right, let me move some stuff around. All right, the first thing I want to do is, because I eventually want to deploy this package, I am going to create a new project, and we'll create a class library for the .NET framework. And I don't want to call it class library 1 because I want to make sure I don't have a name conflict with NuGet.org. So if I go to NuGet.org, class library 1. Now, has anyone built an application called class library 1? Well, no, but there's close to them. So testnet standard class library, CoreNet class library. Yeah, someone's been playing around just pushing up their general CRUD. Remember a couple hours ago when I was talking about what's a good package versus a bad project? I probably wouldn't use class library 1 sample. Not necessarily what I would call a good package, but it's up here and it's a part of the list. But I need to make sure I use something that wouldn't normally be used by anyone else. So I'm just going to call mine Griffin. I'll call mine Griffin calculator. Now, just for fun, let's make sure there's... Now, don't anyone go start registering Griffin calculator on the fly. Now, let's just make sure that no one took my name. I don't think so. I think I'm safe. So I'll call mine Griffin calculator. And it's a class library. So it's meant to be used inside of other projects. And Griffin calculator is going to really just have one little method in it called add. And add's going to take 2 numbers. And we'll call this Griff calculator. And let's tell ReSharper to rename our file. And what's add going to do? Well, add only can do one thing. It takes X and Y and it returns a result. All right, I know it's a really complex piece of software. So Griffin calculator is a success, right? Now let's take this and let's go back out to the command line. I'm going to go out to my working folder. So we'll say working Griffin calculator. And I'll go to the project layer. So I don't want to go to the solution. A solution is a collection of projects, and you don't package a solution. You package one project in particular, because that's really the one thing that would get referenced. Now, if that package has references to other projects, that all gets figured out at build time. So it's not the thing that we're not stressing about that right now. So we want to go to the CS proj layer, and I want to run a command. So I'm going to say, so NuGet pack. And NuGet pack is going to ask for the CS proj file. And what this will do, it'll go look to say, all right, well, you used MS build. We have the files inside of bin debug. Kevin, you didn't designate a description. You didn't designate an author. So we just filled it in with some defaults, but it created a package, griffin.calculator 1.0.0.newpack. So we can see it right here. Now I have a utility on my computer called NuGet Package Explorer that lets me look inside of NuGet packages. If I go look inside of that NuGet package, it'll tell me all the metadata. All right, this is called Griffin Calculator 1.0. Here's all the CRUD. But this is all the CRUD that we would see on NuGet.org or inside of managed NuGet packages. But most importantly, inside of it is the library folder. We're targeting .NET 4.6 because I didn't change that. And I have my DLL for griffin.calculator.dll. And because I pointed at the CS project file, it did all this work for me automatically. I really didn't have to worry about this. You're all probably commonly used to using NuGet from NuGet.org. But I also want to show you how you can use these locally, or as Patrick called it earlier, poor man's NuGet. And then there's also private package repositories, which we probably won't get to today. We'll cover local use, and we'll also talk about pushing it up to NuGet.org. So I'm back at my command prompt. Let's do a little bit of setup real fast. So I have this new pack file, and I'm going to just copy this. And I'm going to say copy, and I'm going to go back up to my top level, and I'm going to create a new folder. We'll call this packages. Yep. So packages, and I'll drop the NuGet package in there. Well, I'm going to open up a brand new version of Visual Studio very quickly. All right, while Visual Studio loads, let me talk about some of the theories. So the theory is I will have a central place where packages are going to live. And see that my packages are uniquely named, Griffin.calculator 1.0.1. And this could be a local directory. It could be a shared folder, maybe a UNC path, or some sort of map drive. And it actually doesn't matter where the files live. If this is somewhere shared that everyone can talk to, as long as everyone sets up their Visual Studio to point to this folder, they all can access these files directly within inside of NuGet. All right, so now I'm going to go and create a new, we'll say a console application. We'll put this under working, and we'll call it console app 1 because it doesn't matter. But before I can just say manage NuGet packages, I have to go create what's called a new package source. All right, so we'll manage package NuGet packages, and all right, NuGet.org is the package source. So we didn't really talk about this dropdown, but there's various package sources that we can use. There's Visual Studio offline packages that are cached on our local machine. There's NuGet.org. I can also add my own. So I have one here for an old NuGet instance. I'll take that out. I have an old local packages. Let me take that out. But let's start fresh. So if you were looking at Visual Studio, you want to point Visual Studio to that packages folder. We can do that by saying new package source. Let's give it a name. So we'll call this local packages. And you can name it anything you want. The name doesn't matter. The source, though, does matter. We want to point it to the directory we're just working in. So I'll point it to packages. And I'll hit update. And what update does is it tells Visual Studio, go read that folder and pull out any package information that you see. If I go not installed, but browse, and then tell Visual Studio, change your package source, give it a second, we see that my package pops up. And I know this is one of those bad packages. It just doesn't have any good information on it. But I wrote it, so it must be trustworthy, right? Well, the latest version is 1.0.0 because that's all I built. I can come in and I can install that package, and Visual Studio will say, okay, NuGet does its work. It creates a cached version of it inside of my solution. I get my packages.config file that has Griffin.calculator 1.0.0. Now I can go into my program CS, and let's start using it. Now what's my class called? I don't remember now. Griff. So it's Griffin calculator, Griff calculator, calc equals new calculator, and we'll tell calc to add 10 and 10. We'll do console write line. And let's be fancy about it. We'll say x plus y is equal to calc.add x and y. We'll take that out. And we'll define everything above. So int x is equal to 10, y is equal to 20. And all right, so let me get everything straight. Now, if we run this, hey, everything magically works. So we're good to go. We successfully used our library. We turned it into a package. We put the package somewhere where everyone could grab it if they wanted to. And we used it successfully inside of an application. But we're not done yet. Let's imagine this is my kitchen sink. So me or another guy or girl or whoever is sitting out there going, oh, that adds good, but what you really need is subtract. So let's go add subtract. And subtract takes two integers and returns x minus y. Now, not just that, let's go set some metadata on this project. So I'll go into properties. We'll go to assembly information and we'll set all the calc library. It's by Griffin. And we'll up the file. So this is assembly1. Say OK. We'll save all that and we'll do a build. Well, let's go back out to handy command prompt and let's rerun our NuGet pack command. Now, hopefully, it should not complain about description or name or anything, but it spits out a brand new file. But this one's versioned a little bit differently. I upped the version. So now it's 1.1.0. Well, let's go find that guy. All right, let's Griffin calculator. Let's go to Griffin calculator. Here's my new pack file. I'm going to copy that. And I'll go to packages and I'll drop it in there. So now I have two packages, not just the one. I'm not overwriting the file. Let's go back to console app. Let's go back to NuGet. NuGet is smart. It has already picked up the change. So notice right here on the right side, it says, well, you have 1.0 installed, but 1.1 is available. My updates tab is telling me as well there's available update. If we look, it's stable version 1.1.0. Everything's good to go. I can click update to change 1.0 to 1.1. Go back over into programs. Now I can say console write line. Let's write this big line all over again. So x minus y is equal to calc dot. I should now have subtract. So subtract x and y. And all was right in the world. Let's run it, just make sure everything works correctly. 10 minus 20 is negative 10. Now we've done some good. We build packages and we put packages in a common place that everyone can find them. This actually works really well for probably a lot of our internal use cases because NuGet is still going to treat it like it's a package. It will manage the updates. And as long as I don't go through and just start deleting older versions of this, I should have a good enough workflow for most small 1 or 2 person shops. Let me show you NuSpec really quickly because NuSpec's fun. To create a new spec file, let's use our NuGet command and let's type NuGet spec. This is going to look at my current project and it's going to do some work for me and it's going to create this thing called a new spec file. Now a new spec file is a specification for the package, which includes all the metadata, includes all the dependencies, and includes all that good stuff. Let's go back to Griffin calculator, and Griffin calculator has no dependencies. Let's go add a dependency real fast, and we'll add our good old favorite friend Newtonsoft. All right, so now I have a Newtonsoft dependency. If I go through and up the version real quickly, let's make this 1.2. Very quick build, and we will run NuGet pack again. Oh, it's using my new spec file. Let me give her that new spec file real fast because I want to show you this without new spec. All right, there we go. All right, let's delete that guy because that package does not contain what you think it contains. All right, so it looked at my configuration. I also saw I had packages that config file. So it went through all my dependencies for Griffin calculator, and it said, okay, those are dependencies of the package. That means my 1.2.0 package, if I copy that, we'll move it into packages. We'll go back over here to console app, and console app should get an upgrade. So I have an update available. Now, not just that. So 1.0 has no dependencies. 1.1 has no dependencies. 1.2 has a dependency on Newtonsoft.json. That means not only will NuGet install my reference, but it will also download Newtonsoft.json and install that reference for me on my behalf. So I will tell it, get the latest, hit update. It's going to tell me I'm making the change. I'm updating 1.1 to 1.2. I'm also going to install Newtonsoft.json. Hit OK. If we look over in our Solution Explorer, we now have, all right, there's Griffin.calculator, and there's also Newtonsoft.json. Now, I'm not actually using it. That's not important. What's important is that it added the reference because I might, in the future, possibly need that reference. All right, so now let me step back and let's talk about new spec. So I'm going to create a new spec file, and let's go into our Griffin calculator. Show all files, and new spec's right here. I'm going to add new spec to the project. We'll open it up in Visual Studio. There's a lot of stuff in here. Now, what it's meant to do is run through a build process. So a lot of blanks to get filled in. We're going to manually fill in some of these blanks. So calculator, the current version is, we'll say 1.3.0. We'll give it a title. So this is Griffin calculator. Who's the author? Well, I'm the author, Kevin. Who's the owner? Well, I'm the owner, Kevin. License URL. The reason I'm filling all these in is if I don't, it's going to give me some warnings. So we'll say kevgriffin.com. And that's the URL and the URL. I'm going to take out icon URL because I don't care. Description. This is my calc. Release notes. So if I have changes between each version of the package, I can put those notes in here. So I can update this with every single release. Copyright 2017, that's fine. Then we'll say tag. So this is called calculator. This is awesome, cool. That part doesn't matter. All right, let's go back out to our command line. So you saw before I could run the CS proj and would run the spec file, or I could tell it to just run the spec file. So we'll call this Griffin calculator new spec. All right, so it's giving me a couple warnings. So the warning in particular is looking at is assembly outside of lib folder. The assembly bin /debug /griffin calculator.dll is not inside a lib folder and thence won't be added as a reference. So, well, what does that mean? It means I have a potentially broken package. Remember a couple minutes ago, I showed you the NuGet package explorer, and it shows you what's inside of a package. There's metadata. Here you see my new dependencies. I have my libraries, and the lib folder in the framework version, those are ultimately what gets referenced in Visual Studio. I'm going to open the 1.3. So 1.3 is a little bit different. Now I got all this really cool metadata. There's IDs, there's versions, authors, tags, license terms, package information. That's all stuff it pulled out of my new spec file. But I don't have dependencies. And also, look at this package contents. This is not what I want to install in Visual Studio. This is more stuff that will just get dumped inside of the solution. So Griffin, calculator. There's a lot of junk in here, and this is not what I want to distribute. But that's all the new spec file knew to install because it really didn't know any better. Let's take a step back and let's fix this particular problem. let's see. I am going to, first things first, I'm going to delete the bad package. I'm going to go back into Visual Studio, and we're going to add a little bit of build automation to this project. So I'll go into Properties. We'll go to Build Events, and then we'll say under Post Build Events, if everything builds successfully, I want to copy all of our DLLs plus Griffin dot calculator. And I want to copy these to a special folder called build. So let me make sure I did all this right. We'll find out in a minute if I did it wrong. All right, build succeeded. The reason I did this was I don't want to do all the work inside of my bin debug release folders. I want to do everything inside of its own contained folder. So that one's called build. Build has the new spec and also has the lib, but specifically lib.NET 4.6 and plus Griffin calculator and any of its dependencies. Now, I'm also going to go into new spec. I'm going to add another piece of metadata called dependencies. And let's make sure I do this part right. Dependency, we'll call this name newtonsoft.json, and then version 10.0.3. I think I did that right. We'll find out in a minute. Let me run this build one more time. Everything built successfully. Now I'm going to go into my build folder, and we'll run the pack file all over again. All right, so what did I do wrong? Oh, do a very quick build to get a fresh copy of that file. Let's run NuGet pack again. All right, so I still have some sample data in there, that's fine. But this built a more legitimate version of the file. So there's my new NuGet package. Let's go inside and look at it. All right, so new updated metadata, but there's my actual dependencies, Griffin, calculator, JSON.NET. Now I could take this and I could copy it into my packages folder. I could go back into my console app, let's hit refresh. There's a new updated version of my dependency, and everything should still technically work. Yep, build successful. All right, let's go back over here and pull up my sample new spec file on the other side. Ah, that's what I did wrong. So it's dependencies and it's ID and version. All right, let's rebuild this. Let's increment the value. I am still pretty sure that this goes inside of metadata. There we go. Okay, so everything's built out separately. So now I have a 1.4 NuGet package. And what's important is that now that I've added that dependency, I specifically added that dependency, is now referenced as the dependency inside of my package. Like before, where the NuGet package was being built because of the CS proj, and all the information was in the CS proj file. And NuGet was smart enough to figure out, oh, you have a dependency on X, Y, and Z. The new spec file is telling NuGet exactly what it is it needs to go get. So maybe I have certain build dependencies, but I might not have runtime dependencies. Your use case might be different. You might also have different versions that you're targeting. So .NET 4.5 versus 5.6 versus 3.5 versus core versus standard 1.3, 1.6, 2.0. You can have all of those different versions inside of one NuGet package. But in order for that to work, you would have to have an external build process that can go build all the various versions of those assemblies, and then NuSpec brings them all together. Like newtonsoft.json, if we look at his lib, there's various versions, 2.0, 3.5, 4.0, so on, so on, so on. It's not one version of Visual Studio or one version of MS Build that's building all these at the same time. It's different build processes building all these assemblies, and then the build process brings them all together so we can build out this big NuGet package. I highly recommend this NuGet Package Explorer. utility. Go download it. It has everything inside of it. It's really useful just for building out your first couple packages. Now let's take this and let's do something useful with it. Let's push it up into NuGet. Now let's go ahead and assume you have a NuGet.org account. So NuGet.org, go sign in. I use my Microsoft account. Now if I go to NuGet.org, anyone can create an account. That's not a big deal. You can manage your own packages. You can even upload packages directly from the interface. You just upload that NuGet package. So this is the one thing I have currently published and listed. But you want to go to API keys. And API keys, you can create one, you can create multiple. You can create some that have limited access, some that don't. If you're using a shared account for maybe a corporation, this is a really good idea to make sure different people have different keys. They expire within a period of time. So if you don't trust someone or only want to trust them for a limited amount of time, you can have the key only last for maybe a week or 2 weeks. I do mine for the maximum, which is a year, and you'll get an email from NuGet.org when your key is about to expire. But I have already taken my key, and I've gone to command line. You can tell NuGet to set API key, and then you put the key in place. When you do that, NuGet will automatically configure the system to use that API key. Just for sake of time, I'm going to do this from the command line. All right, so upload our package. All right, verify our metadata. So it's going to look in the NuGet package. It knows everything that it needs to know about the particular package itself. We know the ID, we know the version. I don't have some of these other metadata things set, so there's no language, no development dependencies. I do have library dependencies, so we do rely on newtonsoft.json. I can change anything in here that I want to, so maybe title, description, so on, so on. I don't have to do any of this. I can also import documentation. You notice how we earlier, a couple hours ago, went to a couple of the various packages, and we saw there was no documentation. It's because no one's filling this stuff out. But I could point it to a markdown file or some sort of local file on my machine. Let's hit submit. And my package is now up on NuGet.org. So, but it hasn't been indexed yet. That takes a couple minutes. But if we scroll down, we see current version is 1.4.0. Awesome. It's listed. It's valid. Because I'm the owner, I have a lot more options here than most people normally would have. And the indexer runs every couple minutes. It's a job process. Let me turn off NuGet.org. But what should technically happen is because I'm looking at NuGet.org and my packages are named the same, Griffin.calculator versus Griffin.calculator. Because they're named the same, NuGet will assume they are the same package because of naming. There's one thing to keep in mind is if you're jumping back and forth between local packages or UNC shared packages and packages up on a repository, if you have a package that's named the same, NuGet's going to treat them the same. So I might have Griffin Calculator local that's different than Griffin Calculator up on NuGet. NuGet will key based off of the name. So as long as the name's the same, that's what it's going to search on. NuGet doesn't care that this is GUID number 4B_XYZ. So let's explain for one more time. Let's make one more little change. We'll bump this up to 1.5. We'll go ahead and add one more feature. So we'll say multiply two numbers between x times y. All right, so it's an actual change. Go back to the command line. All right, let's clear, and we'll do NuGet pack. All right, so we rebuilt our file. I'm going to go back to NuGet.org, and I'm going to upload another package. We'll select my 1.5. Now again, I have to go through and I have to verify the metadata, make sure this is everything that I expect it to be. but it's all good because we are technically uploading a completely different package. It's the same package as in it's named the same, but it's a different package like my packages file. These are all 4 different packages. They're the same package because they're named Griffin.calculator, but as we see here, 1.4.0 is the old version, 1.5.0 is the current version. And if I want to do pre-release, I could call it 1.5.0-beta or dash beta 1 dash beta 2. Those are all considered completely separate packages altogether. It's indexed. So remember, this Griffin.calculator package initially got installed because of local packages. But local packages only go up to 1.3. If I change my package source to NuGet.org, Griffin calculator is what's sent to NuGet.org, and NuGet.org says, well, I have version 1.4. Well, even though we just uploaded 1.5, the indexer hasn't run yet. So I can hit update, and it'll update my package. It'll go from old package to new package. And oh, look, in that time, it indexed, and now we're running 1.5. So I could update it one more time. And again, this is pulling from NuGet.org. If you're playing at home, go to NuGet and download my Griffin.calculator sample. Then finally, we can go to console and we can say multiply X and Y. Alrighty. And everything works. Thank you all so much for hanging out with me. And thank you to the good folks at Inedo for hosting me. And thank you all so much.